So if you recall, we spent some time earlier this year learning about parent functions, and we learned about three different types: y equals absolute value of x, y equals x squared, y equals x cubed. Parent functions are the simplest function of a particular operation type. So this y equals x squared is the simplest quadratic you can have. Y equals x cubed is the simplest cubic you can have. And then we learned how to do transformations to those graphs. So if you added a number on the inside to the x, it would affect the x values on the graph in the opposite way. So it would cause it to move left. It would subtract numbers from the x. And if it's not grouped with the x, it affects the y in exactly the same way it appears. Now we've learned these three parent functions, and today we're going to talk about two more. Now in math, there are 12 of them overall. We will not learn all 12 this year, but we will learn about 8 or 9. So the first parent function I want to talk about is y equals square root of x, and the second one I want to talk about is y equals cube root of x. Now, the main thing I want to do on this page is go ahead and get the t-charts down for these. Now, you notice on the previous three that we use -2, -1, 0, 1, and 2. That doesn't make sense on the square root graph because if we plug in negative numbers, we're going to get imaginary numbers back, and those don't appear on an xy plane. So the smallest number it makes sense to use as an x is 0, because the square root of 0 is 0. And then we want to have a t-chart that's easy to use. We don't have to worry about nasty numbers. So we're going to pick as our x values perfect squares. So 1 is a perfect square, 4 is a perfect square, 9 is a perfect square. I could go to 16, but then you think about the size of most of your grids, 16 starts being a really big number. So we're going to stick with just 4 points on this parent graph. Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So this will be the t-chart that we use for this parent graph. Now for the cube root, it is possible to take the cube root of a negative number and get back a real number, because a cube root asks for something that you multiply by itself 3 times to get whatever's underneath. So if I were talking about taking the cube root of, say, -8, I'd want a number that when I multiply by itself 3 times, I get -8. And -2 actually works that way. -2 times -2 times -2 is -8. So what I'm going to do here is basically take my x cubed graph, and the cube root of x is the inverse. It's the opposite effect. So I'm going to reverse the x and y's. Now for those 3 middle points, it doesn't matter. So the cube root of 8 is 2. So those are going to be the t-charts we use when we graph these things. So on the next, on the first page of your guided notes, you're going to fill in those t-charts here. And these are the t-charts we're going to use when we're doing transformations. That is an 8, by the way. All right. Now, you can read through all of this stuff on your own. Most of it is like pretty straightforward if you're looking at the graph. The thing I really want to draw your attention to is this sentence right here, which says the domain of a square root function is limited to values for which the square root function is defined. That basically means that whenever you have a square root function and you want to define its domain without having to graph it, you're going to have to say basically that the thing underneath the radical, by the way, which is called a radicand, that's the number or expression underneath the radical, has to be greater than or equal to 0. So that's how we're going to find the domain, and we're going to talk about how to find range. So, is to notice that the graph of the square root function has an endpoint and an arrow on the other end. This again is because we can't go past 0 in the parent function, because then we'd be taking the square root of a negative number. So when you draw, flashing back to this page of notes here, if you notice there are arrows at both ends of the cube root graph, and this is because you can take cube roots of both positive and negative numbers with no problem. So when you're talking about the domain and range on a cube root, it's going to be all real numbers. So the question about domain and range, so we're going to do one or two of these problems just so you can see how this works. So let's do the first one and the last one. So the first one, I would start by saying, hey, I want to find my domain. So when I want to find my domain, I'm going to set the thing under the radical, greater than or equal to 0, and then solve for x. So the domain of this is going to be all x's greater than or equal to 0. The range I'm going to get after I graph, because it's easier to see it when you visualize. So I'm going to make my t-chart for my parent. And then remember, there's a number grouped with the x here. It's being multiplied by the x. So what that's going to do is divide all the x's by 6. Remember, when it's grouped with the x, it does the opposite of what you think it should. The y's aren't changing. And I just simplified my fractions when I divided by 6. So now I'm going to take that and graph it. So I've got 0, 0, I've got 1/6, 1, and you're just going to have to eyeball it, If it's not perfect, that's okay. 2/3, 2, I may want to move that 1/6 back a little bit. And then 3/2, 3. Now, one of the things that you need to see, I'm going to flip back to the page of before, the graph of a radical, one end is going to have an arrow and the other end is going to have an endpoint. And the one that's the endpoint is always the point that came from the 0, 0 when you did the transformations. So this is going to be the endpoint of this one, and this is going to be the arrow. So now if you look at the graph, the y values start at 0 and go upward. So my range is going to be y is greater than or equal to 0. All right, so let's do number 27 down there. So I'm going to start again with a parent function. Notice that I have a negative 1/5, but it's outside. So that means I'm going to multiply the y values by negative 1/5 because you affect the y's in the exact same way. The x's don't change. And then I'm subtracting 1 from the x, so I'm going to be adding 1 to all the x's, and I'm subtracting 4 outside the radical, so that means I'm going to subtract 4 from all the y's. So when I add 1 to all the x's, and subtract 4 from all the y's, and now I'm going to plot this. So let's see, 1, negative 4, 2, negative 4 1/5, 3, negative 4 2/5. This is going to be really tight. So essentially what you can do on this is, if you don't like how tiny this is basically becoming, if you don't like how tiny and how hard it is to see, you can actually do a scale on here. I'm okay with just sort of eyeballing it and seeing what happens. So let's see, 5. It's about right there. Oof, boy, my drawing is not on point today. 10. It's about like that. So not the easiest one to draw. Now again, one of these is going to have an endpoint, and the other is going to have an arrow. And my number 0, 0 became -1, 1, -4. So that's going to be my endpoint. Here's my arrow. By the way, my domain on this, if I had taken the thing that's under the radical, the radicand, say greater than or equal to 0, my domain is greater than or equal to 1, and you can see that from the graph. And then my range, if I look at the graph, my graph is pretty terrible, but if I look at my t-charts, it's -4 is the endpoint, and then all my y values are getting smaller from there. So it's going to be y is less than or equal to -4. So we're going to do one example dealing with roots where we actually had to calculate it. of a cube root graph, and then I'm going to ask you to work on these on your own. On the square cube roots, you don't. It's always going to be all real numbers. So we're just going to do one example, and I think I'll do number 22 here. So again, we start with a parent graph. Oops. I guess it would be useful if I used the right numbers, huh? And then I'm going to do the transformation. So there's a 1/2 outside. So that means multiply the y's by a half. I didn't actually do it. Wow. This is a great day. All right, so I multiply the y's by 1/2. And then I'm going to add 3 to all the x's and add 1 to all the y's. So add 3 to all the x's and add 1 to all the y's. Now, you notice how we've got this number here, that's an 11, and this is just -5. I need more positive space than negative space. So what I'm going to do when I draw my axes is I'm going to move my y-axis further over to the left. That way I have more space to draw the positive numbers in. So I'm going to plot my numbers. -5, 0, right there. 2, 1/2, right there. 3, 1, 4, 3/2, and 11, 2. And I'm going to connect it. And again, it's not the easiest thing to draw when they're super skinny. And then the arrows at both ends because this goes on forever. And again, the domain and range of this would be all real numbers. All right, so what I'd like you to do is just to spend some time in either in breakout rooms or on your own, working on some graphing problems from the square roots and the cube roots.